colored sheet of paper and let's kind of pull ourselves together and figure out what is given to you and what is not given to you as far as the integration formulas are concerned. So if I'm looking at it with you, it's on the back, okay? We went through differentiation just as a quick review. We have just the basic f of x, I say f prime of x. Then what's the next thing down for differentiation? X to the n, and then n x to the n minus 1. What do we call that?
The power rule?
Power rule, very good, excellent. And then do you guys recognize the ln of x is 1 over x?
Mm-hmm.
How do you do it? That's generic with x. How do we do it with a u?
Du over u.
Du over u. Does that sound, you might want to write that down for yourself. Or we also talked a little bit about e to the x. The derivative of it is e to the x, right? Sine is cosine. Cosine is negative sine. Tan is secant squared. I went a little bit further and I explained to you how to do secant, cosecant, and cotan as well. I showed you how to go through those. UV is like the product rule. They write it a little bit different than I do. The derivative of the first times the second plus the first times the derivative of the second. And then U divided by V is the quotient rule. Low D high minus high D low over low low. So don't look at the last one for the moment. We'll talk a little bit about that later. But if you see, we have gone through pretty much all the differentiation rules. Everybody cool with what I just said?
Mm-hmm.
Okay. So what we're going to do in the same breath is we're going to go through the different integration rules. And then we're going to talk about the last two parts of the integrations. That's the last lesson. Remember I told you something new? That would be the new. Okay. So just kind of keep an eye. This particular page has a lot of good info for you. So it gives you a lot of the good stuff. So first and foremost, if I ask you to integrate something, there's a symbol that I use to show you how to take an integral. Squiggle. It's that squiggle, right? It's a universal, let's take an integral of something. Okay? So there's multiple rules on figuring out how to take the integral. The first is probably the basic rule. Okay? If something is in the actual state of x to the n. Does anybody remember what the actual integration of it is?
Isn't it x to the n?
The n plus 1.
You go up 1 instead of down 1.
And then divide by
That exponential power.
n.
That exponential power. And then one more.
And then
Plus
Add plus c
Plus c.
if you don't have an a and a b.
If you don't have an a and a b. Okay? All right. If you have an a and a b, it is referred to as the fundamental theorem of calculus. Okay? It's the same kind of concept. If you have an a and a b, you approach it the same way you did here. So for example, its integral is that. Okay? At that point, I would tell you that I've actually done the integral of it, complete. Okay? So I say, done the integral, straight line up, remember that?
Mm-hmm.
And I say I'm going to evaluate it from A to B.
Then take an a, stick it in everywhere in a b, and stick it in everywhere and subtract the 2.
Vice versa. Take B
Or yes,
and
yeah.
stick it in first. Take A and stick it in next, and then subtract the 2.
so you just stick it
Top and bottom. So yeah, it would be x to the b plus 1 over b plus 1, right?
Wait, what?
Oh, we stick it in the n?
No, you
No,
don't.
it's the n. Yeah.
You stick it in the x.
I was like,
So it would be easier if I did it as an f of x function. Okay. There. So. There it is. So when you integrate, it becomes the original function, and you evaluate it. Plug the b in first, and subtract the plugged in a. So remember, if there's an a and a b, you don't need a c. Yes?
Where do you get the A and B from?
Okay, those are given. Those are actual, like, if I know what range I'm going to work on, so we'll do a basic for now, okay? So let's say my function is x squared, right? Let's say I want to integrate that. So the way I tell you to integrate it is I'm going to take the integral of x squared. So how do I find the integral of x squared? I add one whole, and I put it over itself, right? Are we good so far? Now, because I don't have a starting and an ending point, I don't have an A and a B. So I'm going to say plus C. And visually, I can show you why that works. So let's say I also have, let's say my new f of x is x squared plus, there we go. Okay, so typically if I'm doing this, I get x to the third over 3 plus 3x. If I'm talking about going the other way with it, so let's start with my original function. Let's say I have x squared, I have x squared plus 3, I have x squared minus 4. First I want you to take the derivative of each of them for me. Okay? So what would the derivative of x squared be?
2x.
What's the derivative of x squared plus 3?
2x.
What's the derivative of x squared minus 4?
2x.
So what do I see?
They're all 2x.
They're all
The
2x.
constant goes away.
Right. So now if I integrate it to go back to its original, okay, I get 2x squared over 2. Would you agree?
Mm-hmm.
Okay, so I'd get 2x squared over 2, which is x squared. Yay me, I did it
Yeah.
right. Right? But what would this one be?
2x.
Also x squared. No, I didn't do it right. You see? So that's why the plus c indicates something could have been added or subtracted to the end of it.
Okay.
Does that make sense?
Just kind of like a placeholder.
Kind of, sort of, because I know that the derivative of each of them is 2x. I know that to take a derivative of it and then to go backwards, it could give me any of those, but I'm not sure which one. Okay, so far so good? Now, back to the a and the b. So I had x squared, and I took its integral, okay? Now I'll get rid of this because that made better sense. Let's say I want to do the same problem. I want to find the integral of x squared, but I want you to tell me the actual value from, let's say, 3 to 5. What does that really mean? Yeah.
3 to 5 when it's, what's it called?
It's a good question.
Underneath.
Right,
the
underneath.
Little line, underneath the line.
Underneath the line,
Where's
perfect.
Okay.
Yes.
The 5 and the 3 are 2 x values.
2 x values.
When it's
So-
0,
So we have 1, 2, 3, 4, 5, right?
Yeah.
And what does x squared typically look like? Well, it's a parabola,
Parabola.
right? And I want to know from 3 to 5, underneath, what am I actually finding from 3 to 5?
The area.
the area under the curve.
The area from 3 to 5. Does that ring a bell?
Mm-hmm.
Okay. When I don't have an A and a B or a 3 and a 5, it's just saying, in general, it could be any of these values. Okay? Because you're not sure where you're looking at. Specifically, I want to know from 3 to 5. So how do I do that? So I'm going to go x cubed over 3. Everybody cool with that integral? And then I'm going to tell you I'm doing it from 3 to 5. And here I didn't have any values. Because x squared could have been any of those spots, and I could have found the area anywhere underneath it. And then what do I do?
Plug in the 5,
Plug in the
subtract
5.
the plugged in 3.
Minus plug in 3. Okay. I get what? 125 over 3 minus 3 times 3 times 3 is 27 over 3. And I get 98, 70, yeah. There you are. Are we good?
Mm-hmm.
Does that kind of ring a bell from last year? A little bit?
Mm-hmm.
Starts to sound a bit familiar. Okay, so that's just the beginning. So how do we handle that? That was just the first on your little list of things. That was your x to the n over that. How do we handle something that looks like this? I'll give you some examples. And I'm going to put a dx to the side of it. What's that mean? That means the derivative had been taken. Now I can take an integral of it. That's all that means.
Which one is that?
This is just an example I have that you don't have. So how do I handle this? 2x minus 3. What do I do? I'm going to take an integral of it, and how do I know that? Because of that, squiggly. No u's.
The parentheses is gonna be, everything that's inside of it is gonna be x. So you don't derive what's inside, you just.
Chain rule.
No, it's not chain rule. There's nothing being applied to it.
What's the power of it right now?
1.
So truly, can't I just say this,
Yeah.
right?
The only time we worry about it is if there's a power.
And truly, can't I say this? Does it mean the same thing?
Yes.
Mm-hmm.
What did I do? I took that 2x minus 3, because it's not squared. It's not square root. I just took it and kind of said, oh, I'm going to take individual integrals of both pieces. Yeah? Okay. So what's the integral of 2x? And how do I do it?
2.
2x squared over 2. Yeah? So far so good?
Yeah.
And then, so I'll clean that up in a minute. And then what's the integral of 3?
3x.
Yeah, right. Did I have an A and a B?
No.
So plus C. Clean it up. X squared minus 3x plus C, you have your answer. Does that ring a bell?
Yeah.
Mm-hmm.
The smiley face is not the official part of the answer, but
They might give you, they might.
Keep your bonus point. I like
they
your
might
style,
if
too.
you're, yeah, I
I
do
like your
too.
style. I'm happy you're happy.
Yeah, I don't think so. I don't think they like you that much. They're not going to say, good job with the smiley face.
So you, just to go to the order them, see if there's an A and a B.
You always see if there's an A and a B.
Okay.
Now what?
It's squared.
So what do I do now?
Right.
No.
Well, you take it, the integral as if it's like, if it's as if 2x plus 1 is an x, and then so do that to 3 over 3
You change
plus c.
a reverse chain rule. Use substitution.
Okay. So, there's 2 ways to attack this one. The first way is to recognize that 2x plus 1 squared is an easy fix. It could be, what? 4x squared plus 4x plus 1. What did I do?
You just factor or FOIL
Foiled
it
it
out.
out, right? And then I could integrate, plus c, life is good, move on.
Mm-hmm.
So let's do that just to see it. So 4x to the third over 3 plus 4x to the second over 2 plus x plus c. Clean it up if you see fit, and you're done. That is because it's a simple square. Now, had the original been 2x plus 1 to the 20th,
Probably not.
you probably would say not so simple, right?
Do it.
But you know, some of you love math so much you could do it.
Fill up an entire page just
Sit there for
solving
20
one problem.
minutes, multiplying it out.
You would remember the binomial expansion and get really excited that you could do it without having to really think about it. But okay, no,
Right.
maybe not.
Yeah,
Right. Or you could use this thing called U substitution.
Let's do this thing.
Let's remind ourselves how it all works. Okay, I'm going to do it the old-fashioned way, and if you can remember how our friend last year did it.
It was.
Yeah, so let's talk
Thank you,
first.
Ty.
Right. Let's go the old-fashioned way. Let's do it my old way, and then we'll go back and review how he did it, and we'll all love him even more. Okay? So the first thing you do is you recognize that something is inside something else. Okay? So the situation I look at right now is I have 2x plus 1, and that is inside of squared. Do you agree?
Yeah.
It's like the outside case is the squared, and then the inside stuff is the 2x plus 1. So the stuff that's on the inside is what you're going to call U.
Me?
U.
Me?
That's right. Like that.
You.
You are 2x plus 1.
Aw.
I know.
I am.
I am 2x plus 1.
You are. That's you now.
Bow before my back.
So, the next thing I need you to do is I need you to take and find du. What does du mean?
The derivative of u.
of that u that you just named. Okay. So du is 2 du dx, because it means du over dx equals 2.
Mm.
Okay.
Okay.
This is what we refer to, by the way, is called a differential, because it could be written as du over dx is 2, and we just bring the 2 over. It's kind of a shortcut to the differential. All right, just FYI.
Just to tell you that you're respecting x.
That's all it is. A lot of people get confused. Why the dx over there? Well, because it's originally d over dx equals something, and then they bring that over. Okay, so far as that makes sense to all? So right now I have a u and a du situation. Ultimately, my goal is to rewrite this original problem in terms of u only. So if I'm looking at this, I have 2x plus 1, I have 2x plus 1, 2x plus 1 is u, or Ryan. So 2x plus 1, we're going to put u here. So it's going to be u squared,
Yeah.
okay? Now, what is du? All right, because remember, I'm trying to rewrite this in terms of du.
2dx.
So I'm looking at it, right, I got a problem, right? I got 2dx. I got dx. So I can change it, and I can put a 2 here. Now I have du. What's the dilemma?
You change something.
I've changed something. So I have to do its alter in order for me not to have really changed it.
You gotta
Pull out its reciprocal up front.
Right, so what's the reciprocal of 2?
1/2.
1/2. There
I
it
really
is.
don't like this.
And that's du.
you're going to disregard all of this.
I know. When we do it
No
like
offense.
See, I'm
Steven.
really happy
No
I
offense,
missed this
but-
lesson and then came back the day after and Ty explained the other way.
You're so good at it, right. Okay, so now what we're going to do is we carry the 1/2 of the ride, and we integrate like the old-fashioned way. So we have u squared, and what's its integral? It's u to the third over 3.
Mm-hmm.
So u to the third over 3, okay. And instead of u, I really actually need to have it in terms of
2x
the
plus 1.
x's, right. So this would be 2x plus 1 to the third over 6, and then don't forget, there's no a and b, so plus c. On a personal level, that's how I always did it. It's how I've been doing the u substitution for, the 2 years I've been teaching. But how in the world did he teach us how to do it? So let's review that.
See if I
My
remember.
mother God said way.
It was so much nicer.
It was a serious lesson because I missed this last one.
Yes.
You take its integral as if 2x plus 1 was just an x, and then the denominator multiply by the
Okay.
derivative of the
so
inside, yeah.
pretend this is just junk, right?
That's not it.
And then we keep it as it is. We take
Yeah.
its integral,
Mhm.
right? Then what do we do?
Times the derivative of the inside in the denominator.
Times the derivative of the inside in the denominator.
It's beautiful.
And you end up with 2x plus 1 to the third over 6 plus c.
Well, it was a lot quicker.
So I must admit that is much nicer.
Sorry, well, I missed, how do you get that?
You
bottom?
blinked your eye, right? I know, I get you. Okay, so the way I know is, he came up with like, why don't you do it this way? I'm like, oh, we should. So, for a moment, just take the derivative of something squared. What would that be? It would be the third over 3. So whatever that something is, you keep to the third over 3, okay? Then, you take the derivative of that inside. Well, what's the derivative of the inside here?
2.
2. You attach it to the bottom, and you clean it up.
Can't wait to get one where it's like a chain within a chain within a
I know, because that makes it so nice.
Potion.
And I'm just gonna die.
So let's do, he won't, no dying. No.
Get that board off that window.
That was so nice of him, as shy as he was to get up and do that, and show us how to do it, right?
How well did he do on that test?
Yeah. Anyway,
But
there we go.
at least probably better.
All right, try that one without me.
4 points, come on.
We can do it.
If you choose to. How we feeling? Does it like sound familiar to most?
Yes, coming back.
Coming back, right? It doesn't take a while.
I think people tend to forget the plus c.
That is a problem because eventually you don't really use a plus c as you get into more mature parts of the calculus. You have other things to do. You don't have the plus c. So a lot of times it's like from the beginning of calculus, you have to utilize the plus C a lot, and then it goes into, you don't use it as much.
Where we are now.
Yeah. Okay, so
By the exam, we won't need it anymore.
maybe once or twice.
Well, ultimately, you would plug in something for C.
Right.
Yeah, you can solve for C.
Okay. Give that one a try.
I remember how to do this. Third period.
I'm telling you, I've seen you dance. No. You may not.
Liebler might.
I did.
Liebler.
Liebler likes me. He's got a crush. I told him no more.
He told him no more.
Oh, when he introduced me to his girlfriend, I said, "We're through." All right. Did everybody rewrite it correctly first?
Yes.
Yeah. Okay. So use the.
Oh, it's 2x? Oh, yeah.
Okay.
I was thinking of the other one.
Okay, gotcha. So we're going to rewrite the inside. We're going to add one whole,
Yay.
Mhm.
Work.
Look at us.
3 halves, because that's where people get kind of.
1 and a
I
half.
was just
To
saying
the
that.
add 2 halves.
Yeah. Okay, so if I add 2 halves, I get 3 halves. I'm going to put it over 3 halves. We'll play with that in a minute. And then what's the
2.
2?
And it cancels out with the 2, so now it's just 2x plus 4 to the 3 halves over 3 plus C.
Yes.
Oh, that's very cool. So we have 2x plus 4 to the 3 halves. The 2's cancel over 3 plus C. Feeling good?
Yes.
Mhm.
I'm so glad.
This is what I'm good at. Is derivatives and integrals, and that's
This is what you're good at. I know.
Yeah, perfect now.
But we're going to throw in some sines, cosines, e to the x, and ln of
We're gonna
x.
throw in other stuff. Yes.
The numbers.
Yeah. Ellen.
When there's no numbers and there's words in the map.
Well, that's
Volume of the graph.
it. Would be
The
that.
volume of the crap.
Well, you have to do that.
Exactly.
No, that's why I said it.
It sounds like it should be.
Yeah, what did you do in the denominator?
Bring it up. No.
We're doing
Quotient
quotient.
rule. Teach us.
Crying.
No.
Teach us.
Reverse. No.
Ah.
Reverse quotient?
Something special.
Not really.
Not
Oh,
really.
you
What
just
do you?
pull the X up. X
That's what I said. and She said no.
Well, you could, but to me it doesn't feel right.
Just take the integral of the top and take the integral of the bottom.
Separate it.
Say a couple
X,
magic words.
well, it'll clarify out or cancel out to 1 plus 4 over x squared.
Oh,
Yeah.
so it's 4 times X and -2, and then you just
Right.
integrate.
Now, if you brought it up to the top and distributed through it, do the same thing, but there's some kind of complication that could arise. You forget to add your exponent when you're multiplying, blah, 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 you know.
Separate, then bring up.
Right,
So it
so
becomes
this is
1
1,
plus.
right? And then this is 4x to the
Negative second.
negative second.
Yeah, it's
Are we good with that?
That's okay.
Yes.
I just wouldn't think to do that because isn't x squared plus 4 is in parentheses, so you can't pull it apart.
The only way that you can separate it like this is if your denominator is a singleton. If you had 2 things on the bottom, you can't separate those.
So if it was x squared plus 1 in the bottom, then
You'd be out of luck.
right.
Every piece would go with that. You wouldn't be out of luck, but there's more to this world than that. But for this example, we'd be out of luck.
This is basically saying you're dividing each of the terms on the top.
By that
The bottom.
singleton on the bottom.
So you can-
Right, right. And you don't want to do that approach if there's 2 things on the bottom.
You would have to bring it to the top.
You do something else. I'll show you. We'll get into that route. So the thing about integrals is every single problem is attacked a little differently. You have to kind of look at it and see the scenario that's happening. You've seen different scenarios so far, and every one of them we had a little technique to get there. This one was the technique that makes it a little easier. Okay, so what's the integral of 1?
X.
X, good. What did we do with that 4, by the way? How did I call it last year?
Goes for the ride.
I said it goes for the ride. Remember that?
Mm-hmm.
And then here, x to the
Negative 1,
over,
negative 1.
and then we know there's no a and a b.
So it's plus C.
Okay, so if we clean her up a little bit,
X minus 4 over x.
that's it.
Plus C.
With last year, I remember, I don't remember what it was, but something, it would go out in front of the integral.
That's what this 4 kind of did.
Oh,
Because
okay.
this is kind of like
Right,
having,
it's just going along.
that's like having this, and then that 4 just came for the ride.
Okay.
So,
Go ahead.
the way we said, could we write it like that? Negative 4 over x?
Right here.
Oh, I didn't see
Yeah,
it.
yeah, I just went backwards. I don't like to go to the right when I'm writing, because then you guys, I'm in front of it, makes sense, right? Here I am and I'm writing it, and people are trying to still. I learned that a long time ago when I was pregnant, because I would go ahead and I'd start going this way with it, and then I'd turn around, it'd be all erased. I'd get back. So I figured out that if I kind of go this way with it, I'm not in front of it first and foremost, nor am I erasing it. The butt does it, it all happens. The things you have to think about when you're a teacher.
He's dying
You
back
made
there. He was
capacity.
Ryan. He was wheezing.
I'm not, okay.
Both the
I'm
Ryans.
not okay.
He can just envision
Not
them.
never.
How do you
Third
learn
period.
that?
No, fifth period. The full-
You need, money from something, something.
Say it again.
Tested one today.
Okay,
Hopefully everybody read.
well,
I mean, I finished.
I have a test as well for the last 2 periods, but I'm gonna make it tomorrow. It's not, in my perspective, I was like, what was I teaching? I can only imagine if I was forgetting, then they were probably going.
You know what I just realized? That Ty's method is just gonna be like, it's gonna be something that you're gonna teach now.
Forever.
Yeah.
I
And
know.
the first years are getting so lucky.
They are. It's been years.
They don't have to, like, honestly, they don't even have to,
You
like,
should do what you just did, teach the U subway and say, or,
Because there are people that like to use Subway better.
are really?
Yeah.
really?
I use
Yeah.
you sub on the exam.
Yeah.
You enjoy your wasted
Yeah.
time.
Yeah.
You enjoy your wasted minutes, your
You
precious,
know, your
precious
professor,
minutes.
you might need to know it when you get to college. Your professor might say.
Too. Well,
You
that's
know.
the problem.
Okay.
It hurts to understand the process.
So, let's look at this, guys, for 2 seconds. Let's talk. I'm going to rewrite this, and I'm hoping you guys all agree. Those are the same thing.
Mm-hmm.
Yes.
Yeah, does that make sense?
You just pulled it apart.
I did. I just pulled it apart. Now, remember how I did this over here where I took the x squared and I brought it up and made x to negative 2?
Mm-hmm.
Let's do that here for a second. So I would have x to the,
-1.
and okay, we're cool, right?
It's,
And
uh,
let's integrate. So what happens?
it's
X to
X
the
to the-
0th
zero.
over 0, which is, well, you can't divide by 0.
Never.
How do you
Yes.
write?
We just broke
undefined?
math.
Undefined.
Okay, so.
And it's not the
where do you
zero.
write undefined?
Was
There's
that a
not-
trick question?
There's not a special symbol or anything?
This is not undefined. That's called the null set, meaning nothing's in it.
Okay.
That's totally different than undefined.
Okay.
Undefined means it doesn't exist.
Just write nope. What's the answer? Nope.
How do you write undefined? Is that my trick question for the day?
That was your spell.
Why don't you write a skull with X's in its size
That
as
would be
undefined?
undefined,
Yeah.
Or just a really big sad face. Like double circled.
Somebody on skis going downhill. Undefined.
Not about to be.
Okay, so
Hey, either go.
you see the problem.
Uh-huh. We broke
If it looked like this, I could do it. If it looked like this, I could do it. When it looked like that, I did it.
Mm-hmm.
When it looks like this, I cannot.
We broke it.
Because I end up with 0 as my denominator.
Mm-hmm.
All right, are we
As
good
long
so
as there's
far?
something left over after you add 1, you can do it.
Because you end up, yeah, you don't have a 0 underneath, right? So this is the only time that we have an issue. Can't happen. But by definition, this is equal to,
Don't bring it back.
now, let's talk for a second. What is the derivative of the natural log of x?
1
1
over
over
x.
x.
So the integral of 1 over
So
x.
what's the integral of 1 over x?
Natural log
ln of x plus c.
of x.
Okay, so it's on your bright colored sheet of paper, both of them,
That's the cool thing.
right? So the derivative of the natural log of x is 1 over x. The integral of 1 over x is the natural log of x. What they don't do for you is they don't explain why this happens.
No, it actually does have it on there.
But it doesn't explain why, does it?
Well, but like when you see that, you know that means absolute value.
Right. It's because if you were to draw the natural log of x, okay? Let's I think we did this right before. If I plugged in values in here, all right, ln of 1, if I plug in a 1 in, I get 0 for my answer, okay? So when I plug a 1, I get 0. If I plug in a 2, I get the ln of 2, which is some number. Something, yeah.
.693.
That's what I thought it was. Okay, good. If I plug in a 3, I get,
1.09
okay, good.
or 1.1
Okay, if I plug in 0,
error.
I get undefined.
Ever.
What does that mean? Doesn't exist, right?
Yep.
If I plug in -1,
Undefined.
undefined.
Yeah.
Okay, okay.
You need a positive number.
What happens if I plug in 1/2? 0.5.
Negative 0.69.
Negative 0.693. Okay. What if I plug in 1/4?
Well, 1/3 would be 1.0, negative 1.9.
Negative 1.38.
Negative 1.38. So what this is telling me is that at 1, 0, I got that, okay? And as I go higher with my numbers, I get a little bit bigger with my numbers. So it kind of grows slowly. And then what happens is I go closer to 0, but not including 0. So 1/2, 1/4, 1/8, 1/12. I go down, and I get closer and closer and closer, but never touch it nor hit it, called an asymptote. Okay, so the ln of x, the graph of the ln of x is this. So when I come up with my answer scheme, I know that the x value, whatever I plug in, has to be positive. Can never be negative or 0. Okay? So that is why the absolute value happens. Just an FYI. Okay? So,
It's a given.
it's a given. So the derivative of ln of x is 1 over x. The integral of 1 over x is ln of the absolute value of x. Again, you don't have to have that memorized. Are you okay?
Mm-hmm.
But what you do have to recognize is that it's always going to be something that has a derivative over itself. So let me explain that to you. Asymptote, asymptote.
Yeah, I just got that right.
I know. You would think that I got it wrong, but it's right, believe it or not. It's one of the things I know. Okay, so anything I have that looks like this, is used in the same regard. In the first place, it can be written as 1 over u du. And we know that the integral of 1 over u, because it can't do u to the -1, right, is going to be the natural log of the absolute value of u plus c. Okay, does that make sense what I just said?
Mm-hmm.
So let me explain what that means. If I want to take the integral of that, that looks nothing like 1 over x, right?
Mm-hmm.
But do me a favor, whenever you have a fraction that you can't split up, like so, okay? I want you to look at this and say, okay, if I make my denominator to be u, and then in my brain I derive it, so what's the derivative of x squared plus 1?
2x.
So do you agree that I have the derivative over the regular thing? I have du over u.
So that's the
Does that make
situation.
sense?
Yeah.
So that is the natural log of the absolute value of u. Well, what's u? It's my denominator.
Mm-hmm.
Okay.
X squared plus 1. Don't forget your plus c.
That's
Literally,
nice.
if you look at your denominator and derive it and you have your numerator there, you're good to go. Yes.
And so you can forget about your numerator. You don't care about the.
Well, yes and no, because we have things, yes.
So that's just if you get a problem where the top is the derivative of the bottom.
Correct.
Okay.
Let me show you something. Is that the bell? Or, I don't know.
Yeah.
Yes.
29, it's 30.
Okay, just give me 1 second. I just want to show you something. Something like that. If I took the derivative of this, what do I get?
2x.
I have 2x there. So what could I do with this problem? I'm good. I could have a split up problem. We'll do that tomorrow.
That's my go-to.
So note to self, always check the denominator is the
Derivative.
That's it. So like in calculus, you're going to have steps. Step